This tutorial illustrates dependent samples T test in SPSS. Here is an example. We want to find out if instruction has an effect on reading performance. And I have the pre-test scores and post-test scores. I want to see if there's a difference between the pre and post-test scores. I got the mean and standard deviations here, but I also can get these from the SPSS. So I'm going to copy and paste the data into SPSS. And these are the data, the pre and post data. I'm going to give a variable name, and I'm also going to reduce the decimals. And these will be done in variable view. So this is my pre-test scores, and this is my post-test scores. Reduce decimals, and go back to data view. So that's how you set up your data for dependent samples t-test. So since these are paired data, paired samples, and we only have 10 students here. Each student has 2 scores. Now we are ready for the test. Go to Analyze, Compare Means, and go to Paired Samples t-test. And I'm going to put the pre and post test scores into the paired variables box. Check on options. Default is fine. 95% confidence intervals. Continue and OK. And the output is here. We have 3 tables. The first table shows we have 10 students, and we have pre-post test scores, the means and standard deviations. You can see that post score, the means is higher than pre-mean. So we want to run a test to see if the pre and post means are statistically significant. We have an additional table which reports out the correlation between the pre and post test scores, because these are paired scores. And we would expect there will be some correlation between pre and post scores, since those students who do better on pre-test, they also tend to do better on the post-test. So there is correlation between these 2 scores. If the correlation is close to 0, then it will be similar to an independent samples. So that was not paired samples, that's independent samples. And we expect some correlation, and because of there's a relationship between these 2 sets of scores, the sampling, the standard error of the mean difference would be smaller for the paired samples than for the independent samples T. The t-test results for paired samples were reported in this table. We can see that the mean difference is 3.1. That's the observed difference from our sample. And that's a standard deviation of the mean difference. If we take into account our sample size, we get the standard error for the mean difference, which is close to 1. And if we compare the mean difference with our standard error, we get our t ratio, which is negative 3.119. As we mentioned before, we compare this t observed value with a t critical value. And usually if our sample size is 30 or larger, the critical t value is around 2. And so since our degree freedom is 9, it's because it's paired sample, 10 minus 1, it's smaller than 30. So we'll look at the sigma value here, the sigma value, which is the observed p-value that's associated with the t. And we compare the observed p-value with the alpha level, or the critical p-value, which is 0.05. In this case, we find our observed p-value is less than 0.05. So we reject the null and conclude that instruction has an effect on the reading performance. Or to put it in other way, the sigma value here means if we take repeated samples, paired samples of this size, we would expect among 100 samples, there's only one sample that we would get a mean difference this large. So that's why the difference we see here is rare. So the difference is not likely due to chance, and we fail to reject null. Another approach to compare the means is to look at the 95% confidence intervals. The observed mean difference is here, negative 3.1. And if we construct a 95% confidence interval around the mean difference, and this is the interval we get, which tells us that if we take repeated paired samples of this size, we would expect 95% of the confidence intervals will in this range. And we compare this with the expected mean difference, which is 0. Since the interval does not include 0, we can also conclude that the pre-mean and the post-mean are statistically different. To write up the results, and here is an example how we report the dependent samples t-test results. And this is a table, and this is a result. So the group on average scored higher on the reading test after instruction, and you report the means and standard deviation. Then before the instruction, again you report the mean and standard deviation for the pre-test. A dependent t-test was performed on the data to see if differences was statistically significant. Results indicated that instruction did significantly influence the performance on the reading test, and you give the t and the p value. And that's the end of the tutorial. Thank you for watching.